Okay, our lesson for today is about exponential function. Okay, when we say exponential function, this is in the form of y equals b raised to x, where x is the exponent or the power and b is our base. Our base is any constant or positive number except for 1. Okay, now let us see if you can identify the following. If it is a valid exponential function or not. Okay, y is equal to 2x squared or 2x raised to the second power. Now, how do we evaluate or how do we identify if this is a valid exponential function or not? Okay, let us see the exponent. The exponent in this equation is 2. So we can say that 2 is a valid exponent. Now, what about the base? Our base is x because that is raised to a power. This is the base. But it has 2x. We have 2x. So I think this is not an exponential function, but it is a polynomial. So this is not a valid exponential function. Okay? Because according to the rule, the base should be any constant or positive number except for number 1. Okay, let us see the next. Y equals negative 2 raised to x. Again, let us check the exponent. That is x. That is valid. X is a valid exponent. And what about the base? It is negative 2. According to the rule, the base should be any constant or positive number except 1. So this is not an exponential function because the base is negative. Okay? Next, y is equal to 1 raised to 2x. Our exponent is 2x. I think this is a valid exponent, but the base is 1. Okay, according to the rule again, the base is any constant or positive number, but not the number 1. Okay, so in this case, this is not an exponential function because our base is 1. Okay, next, let us move to the next. Okay, y is equal to 2 raised to x. Is x a valid exponent? Yes. Is 2 a valid base? Yes, because that's a constant raised to a variable power. So that is a check. That is a valid exponential function. Next, y is equal to 2 raised to negative x. Okay, negative x is a valid exponent. Yes, we can have a negative exponent that is valid. Our base is 2. This is a positive number. So I think this is constant raised to a negative variable power, and this is a valid exponential function. Okay, next. Y is equal to 1/3 raised to x plus 4. Our exponent is x plus 4. This is a valid exponent. Our base is 1/3. This is not a negative number. This is positive. This is not equal to 1. It is less than 1, but still it is not equal to 1. So this is a valid exponential function. Okay? So we already have identified what an exponential function is. So let us move on to the next. Now, let us see, how do we evaluate exponential function? We'll be given values for power x, and then we evaluate. Okay, so f of x is equal to 3 raised to x and f of 2. Okay, if we are given this type of equation of function, we are going all of the x's will be replaced by 2, okay, with a given value here. Okay, so how do we do that? So f of 2 is equal to 3 raised to 2, and that is equal to 9 because 3 squared is equal to 9. 3 times 3 is equal to 9. Okay, next, f of x is equal to 4 raised to negative x and f of 2. Okay, we're going to evaluate this equation at 2. Okay, so f of 2 is equal to 4 raised to negative 2. Now, if we have a negative exponent, what do we need to do? We need to flip the base or get the reciprocal of it, and then the exponent becomes positive. Okay, and the reciprocal of 4 is 1/4, and the exponent becomes positive. So f of 2 is equal to 1/4, 1 over 4 raised to the second power, or that is equal to 1 over 16. Next, we have f of x equals 25 raised to x, and f of 3 over 2. Okay. So if we have a fraction, the numerator is our exponent, or the power, or the exponent. Okay? And the denominator is the root, which means that the base, the given base, will be raised to the power, which is the numerator, and then later we are going to get the root of it. Okay? So we can solve this in two approaches, or we have two solutions for this. Okay, first, f of 3 over 2 equals 25 raised to 3 over 2. Okay, again, in this example, 3 is the exponent and 2 is the root. Okay, how do we write this down? Okay, so we are going to cube 25, or we are going to raise 25 to the power of 3 and then get the square root of it. Okay, after raising 25 to the power of 3, that is only then we can get the square root. Okay, so square root of 15,625, because 25 times 25 times 25 is equal to 15,625. And then we need to get the square root of it. So our answer is 125. Okay, because the square root of 15,625 is 125. Okay, that is one solution. Okay, we have this another solution. Okay, so f of 3 over 2 equals 25 raised to 3 over 2. Okay, so in this solution, unlike the first one, we get the cube of 25 first, and then we square it. This time, since it is easier to manage a smaller number, so we squared, or we get the square root of 25 first, and then after getting the square root of it, we raise it to the power of 3. Okay, so that will be equal to the square root of 25 is 5, and then raised to the third power. So the answer is the same, of course, 125. Okay. Next, f of x equals 1 over 2 raised to x, and f of negative 3. So this time we are given a negative value. So that is equal to f of negative 3 is equal to 1 over 2 raised to negative 3. Again, if we have a negative power, a negative exponent, we need to flip the base or get the reciprocal of the base, and then the negative exponent becomes positive. So what is the um, reciprocal of 1/2? That is 2. And then um, the exponent becomes positive. So we raise this with the third power. Okay, so the negative 3 becomes positive. So that is 2 raised to the third power. That is equal to 8. Okay, did you get it? Very good. Okay, okay, you try this one. F of x equals 3 raised to x and f of 3. Okay, I will give you 10 seconds. Okay, time is up. Let us see. F of 3 is equal to 3 raised to the third power. That is equal to 27. Okay, did you get it right? Very good. So that is very easy. Easy round. Okay, next. F of x is equal to 2 raised to negative x and f of 4. Okay, so as you can see, that is a negative exponent. Negative times the exponent. So what are you going to do? Okay, 10 seconds. Okay, time is up. Okay, f of 4 is equal to 2 raised to negative 4. So again, we have a negative exponent. What did you do? Did you get the reciprocal of it, or did you flip the base? Okay, so that is equal to 1 over 2 raised to 4th power, and that is equal to 1 over 16. Did you get it right? Very good. Okay, let us see the next. F of x equals 8 raised to x and f of 2 over 3. So you are given a fraction here. What will you do? Okay, let us see. I will give you 20 seconds. You can do either of the approaches or the solutions that we have. But if you want to do both solutions, it's up to you. Okay, you can pause anytime so that you will have more time. Okay, let us see. For the solution number 1, f of 2 over 3 is equal to 8 raised to 2 over 3. Again, the numerator is the power or the exponent, and the denominator is the root. Okay, so which means you are going to square 8 and then get the cube root of it. Okay, so this is the cube root of 8 squared. And when you square 8, that is 64. So we need to get the cube root of 64, which is 4. Okay, did you get it right? Very good. Okay, what about the other solution? Okay, f of 2 over 3 is equal to 8 raised to 2 over 3. So we are going to get the cube root of 8 first, and then later we raise it to the second power. So what is the cube root of 8? That is equal to 2, and then you square it, which will give us the same answer, 4. Okay, very good, very easy. Next, f of x equals 1 over 4 raised to x, f of negative 2. 10 seconds. Okay, again, if you need more time, you can pause so that you can get the right answer. You have enough time. to answer. Okay, so let us see. F of negative 2 equals 1 over 4 raised to negative 2. Okay, so that is, you need to flip the base, the 1/4, so that is equal to 4, and the negative 2 exponent becomes positive. So our answer is 4 times 4 is 16. Okay, did you get it right? Very good. Okay, that will be all. Thank you very much. Bye. See you next time.